Hi class, here's another problem that can, in my opinion, can be kind of difficult at first glance at it, but once you kind of work it through, it's actually it's a very simple problem after you work through it a couple times. So why don't you practice it with me? A motorboat can go 10 miles downstream on a river in 20 minutes. It takes 30 minutes for this boat to go back upstream the same 10 miles. Find the speed of the boat. So here is this river, right? And it's 10 miles long, okay? And then this is going downhill or downstream, and obviously the other way is going back upstream. So it takes 20 minutes for the boat to go this direction, 10 miles. And then, obviously, the boat has to fight the current on the way back up, so it's going to take longer for that boat to come back up because it has to fight against the current. It's not going to be as easy. So it takes 30 minutes for this boat to go back upstream. The distance is the same. They both go 10 miles. So find the speed of the boat. So you have the boat speed. It's going to remain constant. The reason why it takes shorter going this direction and longer going this direction is obviously because of the current. If you're going with the current, you're going to go faster. If you're going to go against the current, you're going to go slower. So kind of think this through with me for a second. I guess before we do that, what I want to do is I want to put both of these into miles per hour. So how fast does the boat go downstream? It goes 10 miles in 20 minutes. It goes 10 miles in 20 minutes. So miles per hour would be per, that means divide. So now we're talking about miles per hour. 20 minutes. What fraction is that if I were to put that in respect to hours? 20 minutes, well I know 30 minutes is half of an hour. 20 minutes is a third of an hour, is it not? 20 minutes, 40 minutes would be 2/3. 60 minutes is obviously at 3/3 or 1 total hour. So 20 minutes is 1/3 of an hour. So the boat going downstream, if it goes 10 miles in a third of an hour, 10 divided by a third is 30 miles per hour. 30 miles per hour, and this is going downstream. Now going back upstream, it goes the same 10 miles. However, it doesn't take 20 minutes, it takes 30 minutes. So how many miles per hour does the boat go when it goes against the current? It goes 10 divided by a half of an hour. And 10 divided by a half is 20 miles per hour. This is going upstream, going against the current. So now we're going to set up a system of equations. Here's going to be going downstream. We know that our boat, or our motorboat, we'll just call it B, our boat, along with our current, because we're going down the stream, we know that our boat goes, right up here, 30 miles per hour. So our boat plus our current goes 30 miles per hour. In class, notice when I say boat, it means like the motor of the boat. So the motor aspect of things, along with the current, goes 30 miles per hour. Now when we go against the current, we still have our motor, or our boat. This time we're going against the current, so we're going to subtract the current. When we go with the current, it's going to go faster, we'll add it. When it goes against the current, we will subtract it. That goes 20 miles per hour. So here is our system of equations. We can solve by using substitution or elimination. I think in this one, it's very obvious that we would do elimination. Because for elimination, what is 1b plus 1b, 2b? What is a positive c minus c, 0c? So the c's, the currents, are already eliminated. So that makes things very easy. And now we have that equals 30 plus 20, which is 50. So how fast is the boat we're kind of asking how fast is the motor on that boat. Divide by 2, divide by 2. The boat goes 25 miles per hour. And so when it asks the question, find the speed of the boat, you've just found it. The speed of the boat is 25 miles per hour. Excel Math might ask you, what is the speed of the current? If you want to find the speed of the current, you know that it goes, where's our equations at? You know that the boat, which is 25 miles per hour, plus the current equals 30 miles per hour. The current would obviously have to be 5 then, wouldn't it? Because 25 plus 5 is 30. In the same way, 25 minus the current, which is 5 miles per hour, equals 20. So we know that our current is 5 miles per hour. It might ask for that on Excel Math too. Another thing that I want to point out on Excel Math is that if you have a plane with a tailwind, and then that plane going against the wind, that's going to be the exact same type of problem where you're going to set it up with the plane plus the wind and the plane minus the wind. You're going to put the miles into miles per hour, so on and so forth. You're going to solve it the exact same way. So if you encounter that in Excel Math with the plane or with the boat, this is how you solve it.